Today we should introduce about the integration by parts, and later we should also introduce about the shortcut method of integration by parts called the tabular method. So to where we should use the integration by parts. Actually, if an integration is like that, f of x, g of x, dx, then we should use the integration by parts, where a function is repeatedly can derivative, and where the gx is a function which we can repeatedly integrate over times. So before going to integration by parts, we have to know that what is the first function and what is the second function. We choose first function as easy to derivative repeatedly, and second function easy to integrate. So what is called easy to integrate? Easy to integrate call that the function we know the formula of integration, like sin x dx is equal to minus cos x plus c. Now minus cos x is equal to minus sin x plus c. So we can do repeatedly, and we know the every formula of the integration, like sin x cos x. It is called the primary formula of integration. So we choose the sin x as a second function. If we choose a function like x cube sin x dx, then we know that there is two functions, one is x cube and one is sin x. So we choose the first function as x cube, because x cube can be derivative repeatedly and it is reduced to 0. So one of the most important things is that a function is first function is like that, which is reduced to 0. So x cube is equal to f of x. So f dash x is equal to 3x square, f double dash x is equal to 6x, f triple x is equal to 6, and f equal to 0. So this reduced to 0. So there is a rule in mathematics which is called ILATE rule. So what is ILATE rule? ILATE rule is to know what is first function and what is second function. This is the direction of first function. So I is equal to inverse, L is equal to logarithm, A is equal to algebraic, T is equal to trigonometric, and E is equal to exponential. So if a function, in this function, this is algebraic A and this is trigonometric. So A is first function and T and sin x is equal to second function. This is not a hard and fast rule. There is also exception in this rule. And so what should we know? The function we know not about what is the integration of this function, like sin inverse x dx. We do not know the sin inverse integration of sin inverse x, so we choose it second function, first function, and we do the derivative of this sin inverse x, and we also know the derivative of the sin inverse x, so it is easy to integrate. So we should do it like this: sin inverse x, it is first function, and 1 dx, 1, it is second function. So integration of 1 dx is equal to x plus c. We know this, so it is a known function of integrate. So what is actually the integration by parts rule? Now f of x g of x dx is equal to, if it is first function and if it is second function, then f of x integration of g of x dx minus d by dx of f of x integration of g of x dx. Yeah. This is the rule of integration by parts. Okay, now let's see an example of integration by parts. X cos x dx is equal to, this is first function and this is second function, so x cos x dx minus d by dx of x into cos x dx. So x cos x integration of cos x is sin x minus sin x dx is equal to x sin x plus cos x, because sin x integration of sin x is equal to minus cos x. Okay, so integration of x cos x dx is equal to x sin x plus cos x plus c. Okay, so we have a question, where should we use the integration by parts rule? Actually we have to know to where actually use the integration by parts, because there are several methods in integration, like the substitute, trigonometric substitute, and several process. So we have to know a clear idea about the where to use the integration by parts. If a function is like f of x and g of x multiply dx, then we obviously use the integration by parts rule. If the substitute was not happen there, if we cannot substitute here, then we obviously use the integration by parts, like x cube cos x dx. One. Second is, if a function is a single function but we not know the primary formula of this function, like ln x dx, we actually know not about the what is the integration of this function, so we should use the integration by parts rule. By using ln is first function by ILATE rule, and dx 1 is second function, so we should also use this types of integration by using the integration by parts. And third, where any hardest integration can be evaluated by integration by parts. So in these three cases, if a hardest integration we cannot be evaluated by a simple method of substitute and we know not the primary formula, then we should use the integration by parts. So while we are doing the integration by parts, we have to face a problem, that is the problem of repeated function. we have to doing integration by parts by repeatedly 2 and 3 times, like this function. If this cannot be evaluated from this cannot be evaluated by this, and we have to do the same process repeatedly. So to save the time and also the energy, we should introduce the tabular method. It is a shortcut form of integration by parts, but one have to say that all the form of integration cannot be evaluated by the tabular method. It is only a specific rule for some specific integration types of integration, like xq cos x dx, e to the power 2x sin x dx. These types of function which can be repeatedly integrate or derivative repeatedly to reduce 0 or not reduce 0 by get the same function. Like if we derivative this function, we can get the same function with multiply by a constant like 2 e to the power 2x, and if we also derivative this function, then we get 4 e to the power 2x, and so on. So we have, for doing this tabular method, we have to know that what the function can be repeatedly get by over time. So if we doing this integration, then we get it is reduced to 0. So we get two chances. One is reduced to 0 by derivative, and one is get the same function irrespectively what the constant was multiplied with the function. Okay, so now we should use the first function, first types of tabular method, where we use the tabular method. First type, in these types of tabular method, we should use the function that is x square e to the power x dx. Now I have to say that this first function can be reduced to 0, so we can use this tabular method of integration. At first I say that a function which can be reduced to 0 and integration which can be repeatedly do, like e to the power x, it can be repeatedly doing by e to the power x dx is equal to e to the power x plus c e to the power, repeatedly can be repeatedly doing, and this function can be repeatedly derivative to reduce 0. So we can use this tabular method. So by choosing the first function and second function f of x and its derivative g of x and its integration, so we write down this 2x and 2 and 0, so it is reduced to 0 and it can be integrated repeatedly e to the power x, e to the power x, e to the power x, e to the power x. So we choose sign like this, plus minus plus minus. At first way we use the plus minus in this way. So if there is a sign, we also take this in our memory, so we can do this like where we can draw a line. We not take this function e to the power x, we always take second, we use from this start, and we start from the first. So and we not take the 0 because 0 into any somethings will be vanished. Okay, so what will be the integration of this function? So x square e to the power x dx is equal to, it will be multiplied x square e to the power x square e to the power x minus 2x e to the power x plus 2 into e to the power x. So x square e to the power x minus 2x e to the power x plus 2 e to the power x. So integration of this function can be done by this tabular method. So it is so easy and it will be so memorized, and various repeated function can be do in this way with saving a lots of time here. So where can we use? Actually, if you doing any these types of integration in competitive exam, you will be saving a lots of time there. Okay, so you have to memorize that these types of function can be used, can be evaluated by the integration tabular method. And we also introduce the second types of integration which also can be integrate by this help of tabular method. Okay, second type of function integration. Okay, for doing the second types of integration by using the tabular method, we take an example. Okay, so we take an example of e to the power 2x cos x dx. So here we can see that no function can be reduced to 0, but both two function we have ability to do the integration because we know both function integration as a primary formula. So e to the power 2x dx is equal to half e to the power 2x plus c, and also know the cos x dx is equal to sin x plus c, and it can be repeatedly doing without any problem. Okay, so for doing these types of integration, we choose any of them. We not follow always ILATE rule. From this ILATE rule, it can be said that we choose e as a second function, and exponential and t is equal to first function. But here we can saw that we can, there is a exception of ILATE rule, and it also be doing belongs to ILATE rule according to ILATE rule. So I choose the e to the power 2x as a first function and cos x as a second function. I say first that there is no hard and fast rule to maintain the ILATE rule, and there is so many maths there that can without considering the ILATE rule, and it is so easy for doing this. Okay, so e to the power x and its derivatives. Okay, and we choose cos x and its integration. Okay, so e to the power 2x e to the power 2x 2 e to the power 2x 4 e to the power 2x, and it will be continue. And here cos x, we have to write the first function here cos x, and the integration of cos x is sin x, and the integration of sin x is minus cos x. So where should we stop? We stop at that point where the multiple of this function will be same exactly of this function without considering what the constant is multiplied. So if we multiply these two function, we get e to the power 2x cos x, and if we multiply these two function, we get 4 e to the power 2x minus cos x is equal to minus 4 e to the power 2x cos x. So these two functions are exactly same, so we can stop this point, okay, and we take the sine rule as same as the first one, so plus minus plus. Okay, now we take the same method, follow the same way, in this way, okay, in this way. So what should we write? Okay, so e to the power 2x cos x dx is equal to e to the power 2x sin x plus minus minus multiply can be will be plus, okay, 2 e to the power 2x and cos x plus, and we take this integration, so multiply, okay, 4 e to the power 2x minus cos x, and we write down in this way. So we can do multiply this function, and between the integration we take this function, okay. Sorry, I make a mistake of sign, it will be minus, so e to the power 2x sin x plus 2 e to the power 2x cos x minus 4 e to the power 2x cos x. Sorry, it is right, okay. So it will be inside and it will give 5 e to the power 2x cos x dx is equal to e to the power 2x sin x plus 2 e to the power 2x cos x. So the integration is equal to 1 by 5 into e to the power 2x sin x plus 2 e to the power 2x cos x plus c. So it is a very easiest method for doing the integration by parts. This types of two functions, and